In this video, I'm going to go over how to make a 5-number summary and a box and whisker plot and how to find the interquartile range for a set of data. I'm specifically going to use the scores on a recent assignment from our quadratics unit, 804 applications of quadratic functions. So this is actual student data, but I have not included names, so it's okay to share. So I've put the scores in order from lowest to highest, and I need to create my 5-number summary. So to start with that, I need to know what numbers go in a 5-number summary. These are 5 numbers that tell us some things about the shape of our data. If I tell you how my class did on a test, there are several different things that you might be curious about when I'm doing that. You might want to know what was the lowest score, and that would be the minimum, and that's one of our 5 numbers. You might want to know what the middle score was, for some idea of middle. And we have several different measures of center, and the one in a 5-number summary is the median, rather than the mean or the mode. And you might also want to know what was the highest score. So you might want to know the maximum score. But you might also be like, well, how spread out were the scores? Will most people right around here with just one person getting this and one person down here? Or will they spread out more evenly? And to get at that, we need to know the quartiles, which are like the median, but for the upper and lower half of the data. We could call the median the second quartile because the word quartile means 4. Quartile has a helper word for 4 in it. Just like a quart is a quarter of a gallon, or a quarter is a quarter of a dollar, a quartile is a quarter of the data. So just like the median would cut the data in half, quartiles cut it into 4 pieces. So let's find each of these numbers in the 5-number summary. And I'm not going to do them in this order, but we always write them in this order because this order goes from smallest to biggest, and that's an organized way to want them later. But those aren't the easiest order to find these things in. I'll start by finding the minimum. Because my data are already in order, that is the easiest thing to find. Here it is. My minimum is 1. Also easy to find, because my data are in order, is the maximum. Here it is. The median is harder. I have to count in to find it. This is a pretty big list of data, so I might need to use some kind of counting strategy. I'm going to start by counting in 5 on each of them and kind of just keep recentering. And I'm going to do that just as a counting strategy so I don't get lost. So 1, 2, 3, 4, 5. Down here. 1, 2, 3, 4, 5. Back up here. I'll put a little dot there that lets me know that's my first group of 5. 2, 3, 4, 5. Down here. 1, 2, 3, 4, 5. And so now I've narrowed it in, and I can just focus on finding the median, and I can see, oh, I can count in 2 more on each. My median is going to be right here. I have the same number of numbers on this side as I do on this side. And in this case, my median was right between 2 numbers. So I need to take the mean, the average of those 2 numbers. And I can do that by doing 7 plus 8 divided by 2, Or in this case, I could simply eyeball it and know that the number that's halfway between 7 and 8 will be 7.5. But sometimes it's harder if the numbers are further apart from each other, and it's useful to know how to find that. So the median is 7.5. Now I need to find those quartiles. So what I do to find a quartile is I ignore half of the data at a time. First, I'll focus on just this half of the data, and I need to find the middle of it. So I'll do a similar counting in strategy as I did before, but this time I'm counting from these places. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now I can see this will be between 3 and 4. So there's my first quartile. And just like I had to find the middle of 7 and 8, I have to find the middle of 3 and 4, which would be 3 plus 4 divided by 2. And in this case, I can easily see that would be 3.5. I'll use the same approach down at the bottom using a different color for my third quartile. And I'll use that same counting strategy. I know there are more than 10 from doing this counting, so I can do my dots by 5s, and I know that I will then have a simpler problem to think about. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I can see this time my third quartile is 9. It's got 9s on both sides of it. It's going to be 9. I don't need to do anything in particular to find that 9. So now I have all the data I need to find my box and whisker plot to make that. But before I go to another page and do that, I also want to find one more number that is not officially in a 5-number summary, but is super useful to have at this point. And that number is the IQR. And this is the interquartile range. So I could also find the actual range of the data. Perhaps I should do that first. That's not hard to do. The range of the data would be the biggest number, take away the smallest number. So it would be 10 minus 1. And that would tell us that our data has a range of 9. The whole spread of the data is 9. But the IQR, we want just the range of the middle. So rather than wanting the whole range, we want to know where's the middle half. Because I divided my data into halves, and I can do that several different ways. Here's the lower half, here's the upper half, here's the middle half. And then the rest of the data would be outside of that. A quarter of it down here, a quarter of it here, and here's my middle half. So just like the range is the biggest number minus the smallest number, the IQR is the third quartile minus the first quartile. So it would be 9 minus 3.5. And 9 minus 3.5 is 5.5. So my IQR is 5.5. So that tells me the middle half of my data. It's really quite interesting. It takes up most of the space. If I look at how many numbers there are in my whole data, there are only 9. And these are spread out quite a bit. So this tells me that there is a lot of spread in the middle of my data. And when I look at this, yeah, that goes all the way from 4 to 9. That's pretty big. Most of the numbers live in there. Only a few numbers live down here. Very few numbers live up here. because we had a lot of 9s and 10s, and so they pushed those other numbers all the way down to the middle. So that tells us some things about how spread out our data are. And if I really want to visualize that, then I need to make a box and whisker plot. And a box and whisker plot uses a 5-number summary. And to make a box and whisker plot, the easiest way to do that, using student resources if you're doing it by hand, is to take a regular sheet of lined paper and turn it on its side. Because a box and whisker plot lives on a number line. And because it's not just floating in space, but it's on a number line, we can use these lines to create that number line. And the first thing I'm going to do is I'm going to look at what kind of numbers I have. My range is really useful here. That tells me there's only 9 different numbers to space out. My minimum and maximum are useful to tell me where to start and stop. It starts at 1, it goes to 10. Some of these numbers are halves. None of them are different than halves. So that tells me, since a typical sheet of notebook paper has a lot more than 10 lines on it, that what I should probably do is number every other line. And that'll let me have everything nicely spread out and easy to see. So I will do that. And I'll start by making my actual number line right here. Since I'm only going to do one on this sheet of paper, I can put it on this, but I want it maybe a little darker. So I'll go ahead and trace over that ruled line there. Then I can put 1 here, skip a number, 2 here, skip a number, 3 here, skip a number, 4 here, 5. I'm actually skipping lines, not numbers. I didn't say that clearly. And you'll notice I'm writing on the lines. That's 1, that's 2, that's 3. Because I'm using these lines to represent where those numbers are. And that'll make it easier for me to graph my box and whisker plot. And I left some extra space over here. I'm being a little sloppy because I really only need it to here, because that's the biggest number I have. And if I were doing this and I was going to like put it on a poster or otherwise share it in a I need this to look really nice way, I probably should have figured this out in pencil so that I could have put those arrows at exactly the right spot. But for this video, I'm not going to worry about that because it's not an important part of the process in this class. And so then I can translate my 5-number summary and put a box and whisker plot up here. And because I don't need this whole sheet of paper to do that, I'm actually going to fold it in half so that you can more easily see the 5-number summary while I'm doing that. And I'm just doing that because I'm making a video and not because that's necessarily something I would do when doing homework or schoolwork. So I take my minimum of 1 and I put a dot at 1 for my minimum. I take my first quartile, which is at 3.5, so halfway between 3 and 4, which is one of the reasons I chose to skip every other line when doing this. And I can draw a line. That's going to be the first edge of my box. Then I take my median, which is at 7.5, so it's all the way over here. And I draw the next half of my box. And again, if I were trying to do this like for a poster or something where I needed it to look nice, I might put a really faint pencil line under these. Actually, I might as well go ahead and do that now. No, I'm not going to because I don't have an eraser handy. So I might put like a faint pencil guideline here and here to know that these are all going to be the same width. But I'm not worrying about that for this video because I'm trying to show you the process rather than make a beautiful graph that would be poster quality. Third quartile is at 9. So you can see that is much closer to my median than this. And this is starting to show me how my data are spread out. And then at 10, right next to it, is my maximum. So I've taken each of those data points and I've put them onto my graph. And then I can connect them to make my box and whisker plot. So I can take another color and do that. I make a line here to show where that fourth of my data are. Then I can trace all of this to be my box. And like I said, if I were worried about things being beautiful, I'd make sure all of these were the same length. I'm not doing that today. And then I can do the other part, the other whisker there. And this lets me visually see how my data are spread out. I can see this is really big. The middle half of my data has so much spread in it. And then the up here is really small. And so that tells me things got clustered really close together at the upper half. They're more spread out down here. The upper half of my class all got scores really similar to each other. The lower half of the scores were all over the place. And so that tells me useful information. It also tells me that for this data set, I want to use this 5-number summary. I want to use this median and this IQR in order to talk about center and spread, because this is not a symmetrical data set. If it were symmetrical, then the median would be much closer to here, and these whiskers would be closer to the same size. And so this is a good IQR and median data set rather than a good mean and standard deviation data set.